Let's run through problem 4.1a. I'll read through the question and we'll kind of discuss it as we go. You're considering buying a 10-year $1,000 bond with a coupon rate of 9% and semi-annual coupons. So 10 years, semi-annual coupons means there's 20 payments, right? 20 interest payments. Its yield to maturity is 8%. So big picture, when you're contemplating a bond, you have two cash flows to track. One, these 20 semi-annual payments, which is an annuity. So with a bond, we take the present value of an annuity, and it's just those 20, every 6 months, there's interest to be paid back. And then at the end of it, the borrower, the person you buy the bond from, has to pay you back the $1,000. It's a loan. You're loaning them $1,000 and they're making interest payments along the way. And so that's the second piece of this. There's the present value of that $1,000, or however much you'll loan them up front. So we'll solve at least a part of this problem by hand just to show you the math, and it can be done by hand very easily, but we'll focus in on our financial calculator as we solve the problem. So I'll solve it first with a financial calculator, then I'll solve maybe part A with just by hand to show you it can be done, but let's solve it with our financial calculator. Okay, you're considering buying a 10-year $1,000 bond, coupon rate 9%, semi-annual payment, semi-annual coupons. Its yield to maturity is 8%. Calculate the price of the bond today. Here's what we're going to input into our calculator. The N is 20, right? There's 20 semi-annual payments, 20 periods. Our IY is this yield to maturity, and the yield to maturity is 8%, but remember, when you're quoted interest rates, you're quoted for the year. We need to break that into 6 months. So for a 6-month period, that's half. It's 4% per semi-annual payment, right? Per 6-month period. Our PV is unknown. That's what we're solving for. Our payment amount is what we promise, and what we promise is the coupon rate. So it's a $1,000 bond. 9% coupon means it's a $90 payment. But the fact that it's semi-annual, this is $90 per year. Divide by 2 to get your payment, which is $45 per 6-month period. Our F fee is $1,000. That's what we get paid back at the end of this. So we're saying, what's the present value of those cash flows? 20 payments of $45. That's what this is summarizing. And a $1,000 lump sum coming to us at the end of the bond. I smacked my microphone. I said coming to us and smacked my mic. Okay, let's solve it. Hopefully I'm still speaking into the mic. Yeah, my meters are still working. Okay, so let me just clear any information I have in my calculator. I hit 20 as my N, 4 as my IY, PV is unknown, PMT is 45 positive, this is cash flowing to us, 1,000 FV positive, this is cash flowing to us, and I compute the PV, and the answer is, I gotta pay $10.67 to get those cash flows. That's the value of those cash flows today, 1,067.95. And this is not a surprise that it's more than $1,000. The reason is the coupon rate, 9%, is higher than the yield to maturity, 8%. It means our coupon is going to be attractive and people will pay a premium. This is a higher coupon rate than the risk level of the bond might dictate. People will pay a higher amount for it. There's a premium of $67 on this bond. And had the coupon rate been lower, there would be a discount. I think that's the B version of this problem, shows a discount. Assuming no changes in interest rate, calculate the price of the bond in 5 years. So this is asking us, okay, everything else in the bond is equal, but just change the N. What is our new N? Well, 5 years, it's a 10-year bond. 5 years from now, there's 5 years left, which means there's 10 payments left, right? There's 2 payments a year, there's 5 years left. So our N is 10. Everything else is equal. So again, nice feature of the financial calculator. All I do is put in 10 as N. Everything, I could re-input everything, right? Put the IY, but it's already in there. So now I compute PV and I get 1040.55. All right, the third scenario. So that's the answer, right? Assuming no changes, calculate the price of the bond. In 5 years, it's 1040.55. What about the price of the bond in 9 years? Okay, the price of the bond in 9 years. So in 9 years, how many periods are left on the bond? How many interest payments are left? And the answer is, well, I got 1 year left. So there's 2 payments a year, 2 payments. So N is 2 in that circumstance. So I put 2 in as my N, and I compute PV. And I get 1009.43. Okay, there we have it. So we've solved A, B, and C. Part D says, explain the movement in the bond price. We expect bonds over time, as they get closer and closer to the maturity date, in other words, as they're, getting closer and closer to the day they have to pay back, the value gets closer and closer to the face value. Any discount or premium, as we have a premium here, shrinks, right? The premium was $67 today, $40 5 years from now, and $9 9 years from now. The premium's going to go down to zero because they're just going to pay me back $1,000 without a premium or without a discount. So we expect the movement of any bond to be closer and closer to the maturity value as the maturity date approaches. So again, closer and closer to $1,000 face value as the maturity date approaches. Okay, there we have it. We've solved 401A. I will do a little chunk of this by hand, but if that's enough for you, that's enough for you. And it'd be enough for me to hit one of those buttons. Hey, if you're going to stick around, why not hit one of those buttons anyway? It feels good to do it. It feels good. Make you feel good, make me feel good. Okay, let's do this by hand, though, and see how you're coping with doing it by hand. The present value of the annuity is the payment amount. We said the payment was $45. So C is cash flow, the regular cash flow, 45 times 1 minus 1 over 1 plus the interest rate. And this is the IY. This is the yield to maturity divided by 2. So 4%, 1.04 to the power of T, it's 20. Sorry, I'm redoing part A, just to be clear. I'm calculating the bond price. Oh my goodness. Oh, forgive the coughing attack. I will mute that in post. Okay, so we were just kind of coming up with our time period, and what we'd said was, well, we're doing part A, and so for part A, this is a 10-year bond, 20 payments, so our T is 20. I had like a real tickle in my throat there. We divide that by R, which is 0.04. And so there we have it. We have our payment, 45 times, and then what's in brackets. That's going to give the present value of those regular interest periods. What about the present value of the lump sum? Well, again, we're getting paid $1,000 back at the end of the bond. Divide by 1.04, 1 plus R to the T, 1.04 to the power of 20. Okay, let's crunch our numbers, and then I'll stop the video and cough away. 1.04 to the power of 20 is 2.19. 1 minus 2.19. No, 1 over 2.19. So I go 1 over x. Then I go 1 minus that answer. So minus 1, hit the plus minus, 0.54. Divide by 0.04. I get 13.59 times 45. 611.56 is the present value of the interest. Well, what about the $1,000 I get at the end of the bond? You go 1.04 to the power of 20. You divide 1,000 by that, so 1 over x times 1,000. And that's worth 456.39. Add these two together, you can hear a frog in my throat. 611.56 plus 456, let's do it. 611.56 plus 456.39. And we find the present value of our bond is 1067.95. And that's what we had done in our calculator. Now, we could very easily do this for 5 years and 10 years. All you would do if you want to do it for 5 years, you would change this exponent to 10, because that's the amount of time remaining on the bond. You would change this to 10. And if you wanted to do it for 9 years out, you would change the exponent to 2. And this exponent would become 2. And you could solve them all that way. And if you had to, you could. And it's not even that much slower. You could do this by hand reasonably quickly. But we did it with our calculator first, and we have solved the problem. All right. I got to remember to edit the coughing out of the video. Thanks so much for watching, as always, and I'll see you in the next video. Bye-bye.